Welcome back to Econ 180. Today on this little video, I'm going to go over the in-class activity that we did together looking at housing policies. And so I'm going to talk about it a little bit, show you guys how to do the graph. There is an answer key posted that I hope is pretty clear and pretty straightforward. I tried to give a lot of information, but I'll walk you through it right now just to give you a sense of it. Fair warning, it's a more complicated graph than some others, and so I might struggle with the whiteboard a little bit, so enjoy the bloopers. Okay, so all of this is to talk about housing subsidies, right? We wanted to talk about other ways to help low-income households consume more housing and improve their utility. So this looks at two of the policies that we've talked about. We talked about four policies. We talked about a proportional rent subsidy, income grant, housing voucher, and government subsidized housing. And all of those came with different outcomes relative to what our two goals were. So some were better at increasing utility, some were better at increasing consumption of housing. If you remember, the public housing increased the consumption of housing or decreased the negative externality associated with slums the highest and increased utility by the least, whereas the income grant did the best job of increasing utility and the least good job of increasing the housing consumption and that negative externality associated with slum housing. So remember that the income grant and the housing voucher behave very much the same way. The only thing is that there are consumption points on the income grant that are not possible with the housing voucher. We'll talk about that a little bit when we get there. And then for the public housing, or government subsidized housing, when the government just builds the housing themselves, all you're doing is maintaining the same initial low income budget constraint and increasing the quantity of housing consumed at any given price. So you're just sort of drawing a new consumption point that's not possible on the budget constraint, because that consumption of housing, that quantity of housing is now cheaper for the household. But it doesn't change their budget constraint or their ability to buy anything else. So the first thing we want to do is start out with our, so this is a lot like looking at, does that work? No, that doesn't work better. There we go, that's a little better. Looking at utility maximization problems, right? Like you might have done in 100B. So we're going to start with our consumption. Well, let's get some math out of the way, actually, before we get started. So I'm going to pull this up a little closer for me. And so we have our budget constraint is y equals c plus pq. And what I've given you guys in this problem is I've given you income is going to be $3,000. So y equals 3,000. And then the price of C is $2, and the price of Q is $3. And that's one thing that's different that we hadn't done before, was putting a price to the C, the composite good of all other consumption. So that's a little bit different. But what that gives us is our new budget constraint is now $3,000, and you can spend it on either C, which costs $2, or Q, which costs $3, right? So far, so good. To find the endpoints, you just want to see how much C you could consume if you only consumed C, and how much Q you could consume if you only consumed Q. So you sort of start out by setting C to 0. Ooh. And so you'd say, okay, if I spent, that's not going to work. If I spent all $3,000 on everything else and consumed no housing, basically I'm just going to spend $3,000 on C, which costs $2, so it's going to be 3,000 divided by 2. I would consume C equal to 1,500 units of C. On the other hand, if instead of setting Q to 0, I set C to 0, then I want to just consume all Q, and that's going to be $3 each. So I just divide 3,000 by 3. And so if I consume nothing but Q, my Q is going to be 1,000 square feet of housing. So far, so good? Okay. So now I can start building my graph. One more thing, real quick. So I did ask you on this problem to determine the slope of the curve. I kind of forgot that was in there. It's a little more complicated than I want it to be. But to find the slope of the curve, you just want to remember that we're the slope of the budget constraint. You want to remember that we're solving this to put it in y equals mx plus b form, where because we're looking at consumption of C and Q, you want to solve for either Q or C. And it depends on which axis you have Q and C on. So if you're putting Q on your vertical axis, you want to solve for Q in terms of C. So in this case, that would look like, let's go over here and do that really quickly. So that would be y equals 2c plus 3q. I want to solve for q in terms of c, so I'm going to get 3q equals y minus 2c. Q equals y divided by 3 minus 2c divided by 3. So we could simplify that and say, okay, well, if this is y equals mx plus b, like slope-intercept form, then I'm looking at q is equal to some intercept and negative 2/3 c. So the slope of this line is going to be negative 2/3 c. It's a little bit different from what the book did, but it's the same exact format. It's just different because I put numbers in. If we had done it the way the book did, we just take this and say, okay, well, we want to solve y equals c plus p at q in terms of q. And so we'd say, okay, pq, that didn't work either. We'd say, let's see how this works. Y minus c equals pq, and then divide both sides by p, and we get y divided by p minus c divided by p equals q. Oh, q. And then that gives you the slope, which is negative 1 over p. Right? Does that make sense, I hope? I super duper hope so. If not, let me know. If not, go back to the book or put it in the discussion, right? I've got those discussion boards on Canvas for a reason so that you guys can come and tell me like, hey, that makes no sense. Please explain it again, or let me ask you some questions. So now we've got some answers. We've got our endpoints C and Q, so we could either consume 1,000 units of housing or 1,500 units of everything else, or any combination between there. And we have a slope of our budget constraint, which is negative 2/3. And now we can start graphing. So I'm going to go ahead and because I put my slope-intercept form, I put Q on my vertical axis. I'm going to put C down here and Q up here. And then that's a little bit, there it is. It's like working with a mirror. And then I'm going to draw my budget constraint where I can either consume 1,000 units of housing or 1,500 units of everything else. And then in the problem, I say if Q equals 500, how much C is consumed? So that's going to be right here, right? And so that should be pretty simple, right? If our budget constraint is $3,000, it equals $2 for every unit of C plus $3, and we're going to consume 500 units of Q, then you just solve for your value of C. So 3 times 500 is going to be $1,500, which is how much we're going to spend on housing out of our $3,000. And so the rest is going to be spent on everything else. So it's going to be 3,000 minus 1,500 is $1,500 equals $2 for every unit of C, which means we're going to be consuming 1,500 divided by 2, C equals 750. It's a little bit bigger than I want it to be because it's going to get busy down here. So let's make it nice and cute and small. Cool? So far, so good. Yes, that was the easy part. Get to the hard stuff. I will. I want to put a budget constraint up in here, or not a budget constraint, a utility curve to show that this is the initial level of utility for our household that we're going to compare other utility points to. Cool? All right, stay caffeinated, my friends. Number 2 says, okay, what if the government decides to subsidize housing using a proportional rent subsidy, which we measure as some proportion of rent, beta, which is going to be equal to 0.3. That changes our household budget constraint to now be y equals c plus 1 minus beta p q. Because if the government's going to pay 30% of my rent, then I only have to pay 70% of my rent. Does that make sense? So right now we're saying the government pays 30% of your rent, 0.3, beta is 0.3. So my income constraint is whatever I was going to spend on everything else, and then whatever I spend on housing, my price times quantity, I only have to pay 70% of it. So a proportion of my rent is being paid by the government. So now we can fill in our values. So we had same income, same price for C, and now we have 0.7 times 3Q. And so if you multiply 0.7 times 3, you get 2.1 Q. And so basically what this proportional rent subsidy is doing is lowering the price of housing. It's not affecting our consumption of everything else, but what it is going to do is it's going to rotate that budget constraint out so that we can consume higher quantities of housing. So if we wanted to, you do not have to, but if you wanted to solve for the endpoints, the endpoint for consuming everything else stays the same, because the more of everything else you consume, the less housing you consume, the less you get the benefit of that proportional rent subsidy. If you wanted to solve for the endpoint up here, it's on the answer key. The only reason it's on the answer key is because the last time I did this within a class, they wanted to know, and so we did it together, and so I thought, okay, I'll toss it in there. But you do the same thing, right? You would just set C equal to 0, so it'd be $3,000 equals 0, and then it's going to be 2.1 Q. So you divide 3,000 by 2.1, and you get Q is equal to, not dollars, but 1,428.6 square feet. Cool? Don't need to do it. Can if you want to. So now we know we have a steeper slope. We're going to see our household consume a lot more housing and maybe some more of everything else. We do tend to assume that they're going to consume more of everything else just because everything else is a normal good. And so when their income goes up, which it has the effect of rising their income, we're going to expect them to tend to consume a little bit more of everything. But the book makes the point that is an ambiguous outcome. It's not necessarily certain. So this is 1,429 square feet up here. And now I say in the problem, if Q rises to 700, what is the new consumption point? So now we've got $3,000 is our income, plus, equals $2 times C plus 0.7 times $3 times 700 square feet, which means we are now spending a lot more money on housing. So now we're going to pay 0.7 of the total cost of our housing. 3 times 700 square feet is going to be $2,100. And we started out with a budget of $3,000. So now we're going to have Oh, it's only going to end up costing us that 700 square feet of housing is only going to end up costing us $1,470, which means if we subtract that from 3,000, we get the amount of money we can spend on C, which is going to be $1,530 equals 2C, or C equals 765. So now we're going to see our household is going to consume 700 units of housing and 765 units of everything else. So that's 765 and 700. You know what? I'm going to make this higher because I know where this is going and I want it to have room for everything. At campus, I have notes where I go through and do everything on one sheet, and it's so pretty. I did it perfectly once and have never been able to recreate it, and now it's locked away on campus where I can't get it, so I'm going to have to try it again for you guys. But for now, that's our new consumption point with the proportional rent subsidy. So far, so good. We are now at a new higher utility curve. And that sort of worked. Not really. Let's try this one. There we go. And we've achieved our goal of increasing housing consumption and raising utility, right? The last one says, okay, that's a proportional rent subsidy. What if we did an income grant? And an income grant is cash money, right? An income grant is when the government comes in and says, hey, we're just going to give you money. We trust you to spend it properly. So an income grant, though, we want it to be equal to the expenditure associated with the proportional rent subsidy. And the point there is if we set the grant level, the expenditure of the grant equal to the expenditure from the proportional rent subsidy, we can do an apples to apples comparison, right? We're comparing the exact same government expenditure to see what the difference in outcomes is from those different ways of subsidizing housing. So that means we have to figure out how much the government grant would be. And it's going to be equal to beta times the price of housing times the quantity of housing consumed with the proportional rent subsidy. Or, to put it a clearer way, the grant is going to be equal to 0.3 times $3 times the 700 square feet of housing consumed. And that's because, right, the government's going to pay for 30% of this housing expenditure. The household chose to consume 700 units of housing, and the price is $3. So 3 times 700 is 21,100. And so 30% of that expenditure level is going to be $630. So that's our grant. There we go. So now with the income grant, all we're going to do is shift the budget constraint up by the value of the grant. Because what we're doing is we're basically going to say, okay, now your budget constraint is y plus g equals c plus pq. So if our original income was $3,000, now our income is $3,630, which we can spend on everything else or housing. Starting to make sense? So we can solve for the endpoints. We're going to see the households be able to consume more housing and or more of everything else because it's just cash, right? They're just getting a check from the government. It's just like the stimulus package that some of us will be getting for the COVID-19, right? You just get $1,000. The government doesn't tell you how to spend it, or depending, whatever. You get some money. The government doesn't tell you how to spend it. So now we have new endpoints. We can solve for them the same way. The household can either consume everything else or consume housing. If they only consume everything else, they can consume, let's see, it's going to be $3,630 divided by $2 per unit of everything else. Didn't calculate this one in advance. 3630 divided by 2 equals 1850. 1815, I speak English, or $3,630 divided by 3 equals 1,210 square feet. So we'll have a new budget constraint with a new color because that's the kind of person I am. If you didn't know that, you've not been paying attention. The endpoints for this are going to be 1,210 here and 1850 here. And it should be as much as is humanly possible. Take a handy dandy envelope here. The same slope, because that slope is determined by the ratio of the prices of housing and everything else. The reason this slope is different is because the government pays a proportion of the housing cost, so it lowers the cost of housing. So we're going to see it look something like this. All right, I should have drawn that out further. And one of the important things that I know I said in the first video, I want to reiterate again, is that this new income grant budget constraint necessarily contains this consumption bundle. Because this consumption bundle is one of the combinations of housing and everything else that you could buy with this amount of money. Because that's how we got that amount of money, right? We got the value for the income grant from the proportional rent subsidy. So we could consume that proportional rent subsidy quantity of housing and everything else with that expenditure level. But we could also consume all these other combinations of goods and services. And what we're going to find is the utility maximizing household is going to choose a point downstream from the proportional rent subsidy. I did not do a great job of drawing this. Let's give it one more shot. I shouldn't have put the values in first. I should have put the line in first. Learn from my mistakes. Okay. No, I will probably not ask you guys to graph this graph on the final exam. It's going to be hard enough to get any kind of graphing done on the final exam or on the second midterm, just by nature of the fact that, you know, we're not going to be in the same room. And so I'm going to have to ask you to like graph it and upload it like you did for this. And so I'm going to try to keep the graphs fairly straightforward. Also, as much as I love this graph, it's not easy to draw, clearly. Okay, so now we have our new income constraint, we have our new budget constraint, and I say if the new budget constraint gives households the opportunity to consume 915 units of C, what is their consumption point? So now we've got our new budget constraint, which is $3,630. And they're going to spend 2 times 915 on everything else, plus $3 on some, no, not 2, some amount of housing. Cool? So we just solve for Q. So 2 times 915 is 1830. Which means we're going to be left with 3630 minus 18. Left my good calculator at work too. I'm really mad about that. We're going to get $1,800 to be spent on Q, which costs $3, which means we'll be consuming 1,800 divided by 3, or U equals 600 square feet. So we're going to be right here in the middle of these two previous points. And we're going to be consuming a lot more of everything else. And this tends to make sense intuitively because that's what we tend to see happen when we give people money. They tend to spend it. They know better what they need. So a lot of development economists talk about how cash transfers and things like the idea of universal basic income tend to be much better in terms of providing higher levels of utility, just because people know what they want. They know what they need better than the government does. But governments are not inclined to do that. So this new consumption point is going to be on a higher utility curve than the previous one, and our household will be made better off. Cool? So on the answer key, I give you the quantities of everything right. With nothing, they're consuming 500 housing and 750 everything else. With a proportional rent subsidy, they consume 700 housing and 675 everything else. With the income grant, they consume 600 housing and 915 everything else. Pretty cool? Let me know what questions you have. I'm really excited to talk about this. One of the things I asked you guys is to think about is why, if income grants do such a good job of improving the well-being of low-income households, why are they so politically unpopular for some groups? It's starting to gain momentum with the universal basic income movement. But generally, whenever we see the government provides some kind of subsidy, whether it's for food or for housing or for healthcare, it's generally pretty heavily constrained. And so think about why that might be, what the motivations are, whether they're economic or political or social, and let me know what you think. All right. Have a wonderful day. Stay healthy. Wash your hands. Let me know all your questions and concerns.